Good day, class. Okay, for the last mechanical manipulator that we will construct, its kinematic diagram. So this is a Cartesian or coordinate manipulator with configurations of PPP or prismatic. Okay. So this is also a 3 degrees of freedom mechanical manipulator. Okay, so let's start. Okay, let's draw the link indicators. So this will start from the base. So our base starts from this is the base. Okay, this is the base up to the center of our prismatic joint. Okay, so this part, okay, this part is the this part is the stand. Okay, remember this class, this is just a stand. Okay, next, so from the center, okay, from the center of this prismatic joint up the center of the next prismatic joint. So this will be our link 2. Next, from the center of this prismatic joint up to the center of the next joint, this will be our link 3. Okay. Then, from the center of this prismatic joint up to the end effector, it will be our link 4. Okay. So this will be our link 4. Okay. So let's label each links. So A1, next is A2, then A3, then let's borrow the A5 from Scara. Okay, this is, oh sorry, A4. So this is A4. Oh, okay. Next are the joint variables. So these are all prismatic. Okay, so we will borrow from our spherical manipulator. Okay, so we will draw this here. Oh, sorry, it's not 3D. Oh, I get it. Okay, it's not yet pointing to the front, to the backward direction. Okay, so it's not. Okay, so this is a backward direction. Okay, so this is where the direction of translation is for the joint 1. So this will be our D sub 1. Okay, so this is D sub 1. Next is for D sub 2. Okay. So D sub 2. Then lastly, D sub 3. Okay, so let's copy this from Scara for our D sub 3. Okay, so we have three prismatic joints. So we have uh, three joint variables labeled as D. Okay, next. So they are all labeled now. Let's assign frames. So let's start from rule 1. Okay. Rule 1, the z-axis must be the axis of rotation for a revolute or twisting, but this is a prismatic. Okay, the direction of translation for a prismatic joint. Okay, we will start our z-axis from the base, but the base is not a joint. Okay, the base is just a stand and a base. Okay, a stand and a base. So we can draw our, oh, I forgot the center. The center of our frames. So the center of our frame for the base is, okay, it's at the center of gravity of the base. Okay. Next, for our first joint, also at the center. For our second joint, also at the center. For our third joint, also at the center. And for our end effector, at the last part, at the last part of our mechanical manipulator. Okay, so line arrow. Okay, so base is not a joint, it's just a base. So we have a choice to draw upward or downward the z-axis, or rightward or leftward, or front or backward. Okay, but because our mechanical manipulator is above the ground, okay, is above the ground, so I will choose uh, the direction of the first arrow, or the first axis, the axis upward. Okay, because the parts of our mechanical manipulator is above the ground. Okay, not under the ground. Okay, so that's the say 0. Next, for z sub 1, okay, the direction of translation is backward. Based on this picture, or based on this illustration, it is a point, the direction of translation is backward. For joint For joint 2, the direction of translation is to the right. For joint 3, the direction of translation is downward. So for our end effector, the direction of translation, direction of z-axis is also downward. Okay, so let's make this z-axis thick for us to see it better. Oops. Okay. Next are the labels. So, okay, the labels. So I will just copy Z0 here. Z0. Z1. Then Z2. Then Z3. Okay, we have fifth frame. Okay, we have fifth frame here. So we will have, oh, we don't have Z4. Okay, we don't have Z4. So this will become Z4. Z4. Okay. Okay, be reminded again, class, this is a 3 degrees of freedom mechanical manipulator, not 4 degrees of freedom mechanical manipulator. Okay? Again, this is 3 degrees of freedom mechanical manipulator. All of them are 3 degrees of freedom mechanical manipulator. Okay? Next, rule 2. The x-axis must be perpendicular both to the z-axis to its own frame and the z-axis of the frame before it. So for the base, we don't have a z-axis before this frame. So I will choose x-axis to the right. Okay, I will draw it to the right. Next, for x sub 1. So z sub 1 is pointing to the back and z sub 0 is pointing upward. So we have only two choices. It's either left or right. So I will choose right. Okay. Next, for x sub 2. Okay, for x sub 2, z sub 1 is pointing to the back. Z sub Z sub 1 is pointing to the back. Z sub 2 is pointing to the right. So our only choices are either upward or downward. So I will choose downward. Okay. So this is x sub 2. Okay. So let's see. Wait a minute. Okay, I will choose upward. I will choose upward. Okay. So this will be x sub 2. For x sub 3, okay, z sub 2 is pointing to the right. Z sub 3 is pointing downward. So our only choices are either front or back. So choose I will choose front. Okay. I will choose to the front. So this will be our x sub 3. Then lastly, for our end effectors x-axis, okay, both z sub 3 and z sub 4 is pointing downward. So I will choose x sub 4 to the front, or I can also choose this x sub 4 to the right or to the left, but I will choose to the front because based on experience, it will be better if x sub 4 will have the same direction as x sub 3. Okay, so this will be x sub 4. Okay, let's go there. Oh, it's too thick. Let's make it thinner. Okay, so this is x sub 4. Okay, next is rule 3. Rule 3 states that each x-axis must intersect the z-axis of the frame before it. So let us leave x sub 0 alone. Next is x sub 1. So let's try to extend z sub 0. Okay, so z sub 0 based from this, z sub 0 intersects with x sub 1. So x sub 1 is compliant to rule 3. Oops, sorry. Next, if we extend z sub 1, it will intersect with x sub 2. So x sub 2 is compliant to rule 3. Next, oh, sorry. Next is x sub 3. Okay, let's fix this. It's not at the center. Okay. So if we extend z sub 2, it will intersect with x sub 3. Okay. So x sub 3 is compliant. Next, z sub 3 to x sub 4. If we extend z sub 3, it will intersect with x sub 4. Okay. So also x sub 4 is compliant to rule 3. So let's leave them like that. So last rule, all frames must follow the right hand rule. So this is about the y axis. So for our base, okay, z axis pointing upward, x axis is pointing to the right. So our y axis will point backward. Okay, to the back. So this will be our y0. Next, okay, z sub 1 is pointing to the back, x sub 1 is pointing to the right. So y axis will point downward. Okay. So this is y sub 1. See, control V. Next, for y sub 2, okay, z sub 2 is pointing to the right, x sub 2 is pointing upward. So y sub 2 will point to the front. Okay, this is y sub 2. Next, is y sub 3. Okay. Z sub 3 is pointing downward. X sub 3 is pointing to the front. Okay. So y sub 3 will point to the left. Okay. So y sub 3 will point to the left. Am I right? Z X. Yes, it will point to the left. Okay. So this will become y sub 3. Okay. Next is y sub 4. Okay. So the end effector frame is the same with frame 3. So let's point the y sub 4 arrow to the left. Okay. So this will become y sub 4. Okay. So again, class, z sub 3 and z sub 4 is not negative. Okay, they are not negative axes. They are positive axes. Whenever you choose a direction, it will become the positive side, while the opposite side will be the negative directions or the negative side. Okay. So this is our kinematic diagram for Cartesian manipulator. Okay.